Man, I am glad to be here. I have never been to Australia. It's going to shock you. I'm not Australian, so I do not sound Australian. I'm not even going to try the accent because Jeremy sounded so bad. So I don't think I can beat that. I know Jeremy's already picked on me, but I told him, remember, I come after you. So, but he's right. I'm not a great developer, so, you know. Couple things about me, just who I am. I am a principal developer advocate at AWS. I've been with AWS for coming up on 5 years. I've been a solutions architect for over 10 years. I'm really old. I am a developer for almost 30 years. I remember when tables came out in HTML. I remember celebrating that. So yes, I'm that old. So I'm a father of 5, husband to 1. She is a superstar. That is not a mistype. I'm going to stop right here, though, because I know this gets confusing. How many of y'all have heard me speak before? Okay, quite a few in the room. Well, I apologize to you because you're going to hear the rules again, because you got to have the rules when I'm speaking, okay? We have some hard, fast rules that you have to abide by. But they're actually guidelines because they're going to help you out, okay? So the first rule is this. This is any number I want it to be. Okay, I'm going to hold this up, and I'm going to say 7, I'm going to say 10, and it's always confusing. You people, someone will come in late, and I'm going to just say there were 10 of us, and they'll be like, that's only 1. The truth is, I can get to 4 if I take my shoes off, but it gets awkward for everybody. I was born this way. I did not wake up this way for the first time this morning. If I did, I would not be here. I would be at that beer place out there. I don't even drink beer, but I'm pretty sure that would cause it. So. I'm very comfortable and make a lot of one-finger jokes. I'm very comfortable with that. However, if that makes you uncomfortable, I'm also comfortable with that. So I'll be good either way, and yeah, I appreciate that. I am a drummer that used to say musician, but people go, really, is that? Turns out I am a phenomenal drummer for one finger, but I'm really average after that. So. And I'm a lover of pizza without pineapple. I don't think pineapple should be anywhere, on pizza. I have a picture. It is proof, photographic proof of Jeremy Daly eating pineapple on a pizza, which means he knows nothing about serverless. So that's how the correlation works. You're welcome. I'm sorry to tell you that in public. I was going to do that in private, but there it is. So just before 2019, or in 2019, just before COVID hit and all that, I got this awesome opportunity to go to Turkey. And I was going to fly into Istanbul, and so I made this long trip, and I flew in, and I landed, and it's a brand new airport in Istanbul, and they had all these fancy customs booths, and I'm standing in line, there's like 20 of us, and I finally get up to the customs booth, and I hand the lady my passport. And I travel a lot for what I do, and one of the things you do not want to see when you hand the person your passport is when they look at it, they scan it, and they go. That's always a red flag, okay? So then she gets on the phone. I don't know what she's saying. It's a lot of languages I don't understand. It's probably just one. I don't understand all of them. So, and she's talking, and I get nervous. I'm standing there about 20 minutes, and I get nervous. I finally lean out around the glass, and I said, what's going on? What's the problem? And she said, get behind the camera. And I said, okay. So I stood there. So a little bit later, out come 2 guards. And I'm not talking just a side pistol like in America. I'm talking full body armor, the guns, the AR, whatever's and stuff. And they come up and they stand right on either side of me. I think, how you going? What are you doing? Then they close the line behind me. And so then they escort me to it was an interrogation room. They called it a conference room. There were no windows, no anything. And and by this time they've got my passport, they've got my driver's license, they've got my global entry card, they've got my mom's Facebook. They've got everything on me they can find. And they sit me down in this room, and then for an hour, nobody will tell me what's going on. And I finally said to the guy, at some point I'm like, I'll get back on the plane. I don't need to come in. And so finally I said to the guy, what is going on? And he said, well, here's the problem. We seem to have some duplicate issue going on. There's an Eric Daniel Johnson, which that's my full name. There's an Eric Daniel Johnson who, and they didn't go into the depths of what he did or didn't do, and he couldn't come in or couldn't come out. But the basic bottom line was he could not cross the border. And he said, we're trying to decide if you're him. And I said, I'm not. And they said, we don't believe you. So here's what I asked him. I said, let me ask you a question. Do you have prints on this guy? And of course, very arrogantly, of course we have prints on this guy. So I said, if you've got more than 2, I'm not your guy. So he picks up the phone and he makes a call and you panic look. I mean, and he puts the phone down and says, Mr. Johnson, you can go. Thank you. I will tell you as a side note, this has no point, but as a side note, I was on the phone. My mom called me just as I was in line. I said, Mom, I'm being detained. I have to go. And I literally heard, what? Here's the problem. They had duplicates in their system. They were not, I can't even say it. How do we say it, Lars? Idempotent. Idempotency. They were struggling with duplicates of the system, and Eric Johnson was paying the price. So today I want to talk about just that. I want to get into what does it mean to be idempotent? What does it mean to have idempotency? This is a word we throw around a lot, and it's funny, do you build idempotent systems? Sure. I built 3 yesterday. So we don't, a lot of times we don't really know what this means, all right? So we're going to kind of get into that. So today's agenda, we're going to talk about what is it. And I'm probably not going to, explain it to all your best wishes. It's really funny because I was sitting at a table last night with actually Steven, who's up there, and he's like, okay, mate, you got to say, there was my Australian, okay, mate, you got to say this, and you got to say this, and when you do this, and I said, dude, I have 25 minutes. So if I do everything he wants, we're going to be here several hours, so we'll see how it goes. So we're going to talk about what is idempotency, and we're going to talk about how do we kind of deal with that. So we're going to look at where can, and AWS specifically, where can duplicates occur? How do we build our idempotency into our code, or building idempotent code, and then using services that are idempotent. So when we think about what is idempotent, what does that mean? So if we look at, this mathematical, remember these are quotes, right? Oh, I didn't finish my rules, hang on. I didn't finish my rules. Let me give you the rest of the rules. These are quotes, not apostrophes. I am not waving at you, unless I am. Okay, that's contextual. But I can do this, or I can do this, which just looks like a bunny, a bad bunny, okay? And these are thumbs. And I do this because this gets me beat up. So there you go. So when we talk about idempotency, the mathematical definition is operations that can be applied multiple times without changing the result. So this, I can't even do this math. This comes off my 5th grader's homework, and I go to explain it, I can't do it. So that's the mathematical definition. Then we have the architectural definition. A message that has the same effect whether it is received once or multiple times. This comes from Hope and Wolf's book, right? But then we have the real world example. And that says, has my credit card been charged twice? A text from my mom, right? And these are things that we deal with on a daily basis. And so as we're building applications, we need to think about how do we maintain idempotent applications. And we're going to talk about before we write the data today. We're not going to get into after and then remediation. But before we write the data, how do we kind of fight against that? All right, so first thing I want to talk about is where can duplications occur? And there's different places that this can happen. The first is duplications are caused by transmission issues. These are, and we're probably seeing it today. Anytime you get a group of people, it's like, oh, the internet went down. I lost my signal, things like that. And this affects us as we're building more and more online applications. So what that looks like is we have this sender, and the sender sends this message, and then we get the acknowledgement back from the receiver, but the network fails. It's like, oh, okay. So what we don't know as the sender, we don't know, did the receiver get it? Did the receiver process it? Did the receiver respond back? So we don't know. So what we do is we go, okay, well, we'll just send it again. All right, so after a timeout, then we get it, and now we've got this possibility of a duplication. We really don't know, do we? Because we don't know where the system failed. And we can try to build, at Amazon we talk about this, and Werner Vogel says everything fails all the time, and that's the truth. We try to build to not fail, but we plan as if it will, because everything fails all the time, right? And so we're going to talk more about that. So let's look at another area where this can happen. Let's talk about some services. All right, so this can be duplication caused by receiver issues. So in this example, this is actually an SQS queue. And so what happens is when you as a sender sends a message in, one of the things we do automatically is we create duplicates, okay? Because we want to make sure we don't lose data. So we create these different duplicates in SQS. And we say, okay, we're going to store that in different places. And then your sender or your receiver will pull for messages. And how this works with SQS is when I do a pull, that particular event is then hidden. It's not removed, it's hidden from the rest of the world. So it sits out there and nobody else can grab it until this receiver has responded with, hey, I finished it, everything's good, that's a 200, or I failed, probably need someone else to give it a shot. Right? So what happens when the receiver blows up? Now, what happens is that event, after a certain amount of time, that becomes available in the SQS queue again. And now, the next receiver grabs it. And now, again, we're stuck with deciding, did my receiver get it? Did I not get an acknowledgement? What happened? Something failed. So, the next way, so that can happen in your receiver. And the next thing that can happen, and it is true, is what if the service has an issue? Okay, like I said, we build to not fail, but plan as if we're going to, right? It's important that we know that, hey, it could happen. So in this scenario, I'm going to send data in, and there's my duplications again, and my receiver's going to grab it, but instead of the receiver blowing up, maybe something happens with SQS, there's an incident or something like that, and it actually kind of blows up on that timeout. So now all of a sudden things are available again, so my next receiver's grabbing it again. So now I have the possibility of a duplicate. All right, so these are things like in the services you really can't change, but you can plan for them. So let's jump into that a little bit. So the first thing we're going to do is we're going to talk about building idempotent code, adding idempotency in this. And one of the things, I'm going to tell you this up front, is the technique I'm going to show you is actually built into our Power Tools. Call out to Power Tools right there. Power Tools, if you're not using Power Tools for Lambda, I strongly encourage it. It does a lot of the grunt work and lifting for you, logging, lots of different things. And one of them is helping you build idempotent. And we just came out with Power Tools for .NET. Is now GA. So, am I right? There it is, yeah. Thank you. I'm going to be real honest, I can't even spell .NET. So, there you go. All right, so, building idempotent code. How do we approach this? So, one thing is we have this idea of idempotency tokens. And there's a couple things that we use. So we use an idempotency token. It uniquely identifies a message to enable receivers to avoid duplicates. All right? So there's a couple of things that make an idempotency key a well-behaved idempotency key. And the first is they're generated by the client. I've seen folks like, well, I'll issue, when the data comes in, I'll issue a token for you. That's no good. The client needs to know, the origination of the call needs to know the ID that we're going to be working with. So we originate that at the client. That can be a web page, your web client, it can be a mobile client, it can be server to server, things like that. But the origination of the call needs to understand what the idempotency token is. Second thing is they are regenerated by the client. It's like, well, that seems non-idempotent for you to say that, Eric. But the truth is, if I go and I need to regenerate, that's because the client knows about it. So he sends the first token, there's a problem in acknowledgement or a problem in the service or a problem with the receiver, so they're going to send it again with the same token. So there's a tracking of the same token. The third is it's a unique per message. Okay, UUID is a very common application that we use for that, but it needs to be unique for message because it's identifying the message. It's important that we say This is the message, and there's no other like it. And if I'm resending it, it's the same way. And finally, use a dedicated field. And we'll talk more about that, but it's very important to say, this is designed for idempotency for you to track through the system. It's not just, oh, just use the ID. Just use that because, well, like I said, we'll get into it later. There's chances of that getting messed up, chances of you losing that. All right, so once we've created this token, what do we do with it? How does it work? So this is an idea of it's basically a representation of a request. So when we make a request, we have this initial request, and they're going to invoke the event. Okay, so here I am, and it could be the client, so Lambda function, and we have some kind of persistence, right? In this example, in the Power Tools example, it's DynamoDB. We actually set that up, and that is where we persist this. So when we make the invocation is done, what happens is we grab that idempotency token that the client is sending in, and we set it inside of DynamoDB, and we lock the record. So we say, this record's being worked on. Anything else coming in, it shouldn't do it if I'm already working with this record, right? Then it's locked in that time. Then we run the Lambda handler. This is your code. Right, so after we've saved that to DynamoDB, we're going to run the Lambda handler really quick, and whatever response comes out of that handler is then written back to DynamoDB. So whatever you're going to output to the client is written to DynamoDB in the record, and it's unlocked. Then what we do is we send that response back to the client. Okay, so what I've got now is I've got this record of the request being made and the results of the request tied to the idempotency token. So this is a success, I can't say that word, is a successful request. There it is, all righty? But what happens when it doesn't work as planned? So let's go back. So we run this request again, it does everything, but when we respond, boom, we blow up. There's a problem in transmission, and that's where that blows up. And now our client's sitting there going, what happened? So after a certain amount of timeout, if we've built that in, we've built retry into our client, which hopefully we have, we then go, okay, well, I'm going to go ahead and send it again. And what it does is it looks up that idempotency token, and it says, oh, we've already done this. It's been done, and rather than processing the handler again and possibly adding duplicates to our table, we're going to go ahead and send you the response that was saved in the database. All right, hopefully that makes sense. So you get this idea of we're saving this record, tying it to an idempotency token, and then we'll talk about how long that should live in a minute. And then when we set a certain amount of time and say any other request coming through with that idempotency token should, instead of processing the system, should just get the response from the database. All right, and then you can just hammer away with that same token, you get the same thing back every time. All right, so that's kind of how we approach that in code. Again, you can build all that out on your own, or if you're using Java, Node, .NET, something like that, Python, I would encourage you to look at the Power Tools because we build a lot of that automatically for you. All right, so the next thing is, now that I've built my code this way, if we're going to get into these app integration services, and I talk a lot about it, and Jeremy was talking about it earlier, we all talked about it, is getting away from code and moving to configuration over code. That means we're using services. So we want to make sure our services are the same, provide the same functionality. And let me show you a couple of examples of how we work with that in AWS. So here's an Amazon SQS FIFO, the send message API for a FIFO queue. So if you were to take, you open your CLI and you say, okay, I'm going to generate a token using UID and I get a token back, okay? And then what I'm going to do is I'm going to go ahead, and we're just going to use the CLI for an example on this, is I'm going to go ahead and make this call, and I'm going to insert as the message deduplication ID, that's the token name, I'm going to insert my token, and then some message body and things like that. Now what happens if I run this again? I get the same thing back again, right? So you'll notice the message IDs match. So it's saved that record, and it's giving me the same thing back. Now, I want to apologize right up front. I'm a little mad at Jeremy. He's now walking away because he knows that too. There he is. I'm a little mad at Jeremy for his fancy slides. So I really feel inadequate at the moment. But those were cool, man. Nice job. So, yeah. So that's how we do that in FIFO, using the same kind of process that I just showed you with code. But what if we're going to do that at the step functions level, okay? So with step functions, we can follow the same process. We're going to create our token. We've gotten good at that. And we're going to go ahead and we're going to actually invoke it. And this time in step functions, it's called the name. It's really clever. We called it name. Okay, so it's the name of your step functions execution. And we get back this, and you notice that this is now tapped on as part of the ARN. All right, so if we run that again with the same thing, we get back the same thing, and our ARNs match. Right? So now we're not rerunning the same one over and over. So if you've ever been running step functions from a CLI, you'll notice I have to change the name when I run it. It can auto-generate for you one for you as well. All right, so let's look at one other service. This obviously is idempotent. So the next one is EventBridge, okay? So with EventBridge, we're going to do the same here. We're actually just going to put our data straight on EventBridge, and we're going to get back this event ID. So I've just done this, source food, detail type, whatever I want. Let's run that again. Notice these do not match. EventBridge is not idempotent. Now, you may be asking yourself, well, what were you thinking? Why didn't you make it idempotent? It's not like we forgot. We got it all built and went, oh, we missed something. Oh, we need 2 more pizza on our 2 pizza teams, right? It's because with EventBridge, the way you're shipping in events, it could be the same event over and over. We don't know. So we don't want to block you and go, well, we recognize that. We're not going to do it again. You need to be able to just drop things in as much as you can. But you also need to have idempotency when you're dealing with EventBridge. So how do you do that? So we go back and we look at our event, and what we can do, so you see here we've got our ID, and what's the rule about a proper idempotency token? We do not use our ID, okay? What if that gets changed? What if something like that? So we don't want to do that, all right? So instead what we're going to do is in our metadata, and this isn't like hard, you have to do it this way, but this is a good suggestion. In our metadata, which is just data under the detail, you could call it metabob for all you want. But in our metadata, we're going to have this idempotency key that is unique to this call, right? So then what happens is when I send that again, so I'm going to generate my token, and then I'm going to send this, and inside of that data, you see I'm adding an idempotency key. It's now idempotent. Now, hang on a sec. But Eric, if I run this again, it's going to just keep giving me new IDs. You're right. To make this idempotent, now the receiver behind the EventBridge, wherever your rule is targeting, needs to evaluate this token, right? So it may be something you save in a DynamoDB database, maybe somewhere you persist that token so you can say, hey, we've seen you before, we're not going to rerun this. So, and that way it can get dropped off. So it might be an interesting place to use pipes. And in enrichment, you look to see if the idempotency exists, and then you drop. That's just right off the top of my head right there. I'm just saying, this is the kind of magic here. So, all right, so that's how you would do that in EventBridge, and that looks a little different. We don't do that automatic for you, but that's by design. All right, so a couple things to talk about. Idempotency duration, right? So these are the defaults. Lambda Power Tools defaults to 1 hour. Amazon SQS FIFO is 5 minutes. SNS FIFO is 5 minutes. Step function start execution is 90 days. You're like, well, that's a pretty big gap, Eric. Well, it is because step functions is a service that can sit out there for up to a year, right? And so we need to give you some room, but you can change some of this up. But one of the things I would really encourage you to understand is when you're setting your TTL, it's important to understand how your workloads evolve, how your access patterns work. Because 5 minutes might be, or 1 hour in the Power Tools might be too short for you. You may need something longer. You may say, look, this is a longer process. Some different things have to happen. We want that to sit out longer. Don't just go, whatever they say. Be prescriptive about how you're setting that. Evaluate your system. Is it the same over here as it is over here? Am I syncing these around to different regions? Different things like that. Idempotency, here's the truth. It's hard. It's a hard thing. And if I tell you that we do it to perfection and you'll never get duplicates, you'd call me big fat liar, because that's what I am, right? Because not always, just right there, that little section. So you're like, I don't know, we'll just ignore everything he just said. He's a big fat liar. But it is hard, but these are tips to start keeping that from happening before you get data into your database. And then, of course, there's some processes, automated processes you can run that you can look for duplicates. But hopefully, you will never be standing in the Turkish airport with a guard on each side of you. And I at one point, I said, do you have any Diet Dr. Pepper? They did not. They said, shut up and eat your pineapple pizza. So, all right, so naming is important, right? So these are some examples of some different folks who name it: Stripe, idempotent key, PayPal request ID, Square, idempotency key. However, I like things. Idempotency by any other name would smell as sweet. The name isn't important except for the fact that it needs to be unique. Long and complicated might be good on this way. This is kind of like password stuff. You don't want to have it overwritten. So let's talk about that for a sec, right? So when we're building applications, especially when you're building distributed applications, we do a lot of middleware, right? A lot of services touch things. And you may leave AWS, you may leave Azure, you may leave GCP, and then come back in, and you may be doing third-party services. So we need to think about that. So let's give you an example. Let's say we have a requester, and that requester sends an ID, or sends a request, and it has a message ID of 123. And that intermediary says, okay, I got that request. Let's go ahead and forward that on, but I'm going to assign my message ID of 456, because message ID is the obvious ID name for a message, right? So then I'm going to say, okay, the replier goes, well, I got that. Now I'm going to assign my message ID of 789, but I know that the requester is expecting a correlation ID of the same ID he sent me, and he sent me 456. Lost in translation, isn't it? So now what happens is these correlation IDs don't line up. That's hard to read, isn't it? 1, 2, 3, bang, equals, which they told me earlier that means does not equal. Does not equal the same. So you need to be very careful how you name these and how you lay these out. All right, so hopefully that helps as you're talking through idempotency. I encourage you, I put together a link. I actually talked about this quite a bit at reInvent as well. Put together this link. This is on Serverless Land. If you're familiar with serverlessland.com. If you're not, check it out. Serverlessland.com is a site that our team manages, and we put together, we curate a lot of stuff. There's thousands upon thousands of videos, blogs, everything like that. So I encourage you to follow me on Twitter. I'm EDJ Geek. Here's the warning. I talk about serverless a lot. That's good. I talk about my family a lot. That's maybe good, maybe bad. Depends on how I'm feeling that day. I do rail against pineapple on pizza. Apparently, Emily, one of our ladies I work with, she said, I've blocked you because you say pineapple too much. So that happens. And with that, I'm going to give you back some time. We're going to go to break. And ask me if you have any questions. Come see me at the coffee booth, Serverless Espresso. And I appreciate your time. Thank you.